Can we protect the crop yield using spaceborne Earth observations and numerical weather predictions? The work presented in this video is titled Semi-Supervised Phenology Estimation in Cotton Parcels with Sentinel-2 Time Series. My name is Vasilis Konstantinou and I work as an Artificial Intelligence for Earth Observation Research Associate at the National Observatory of Athens and the Beyond Center of Excellence. Crop yield is exposed to a number of risks that result in volatile farm profit and hence an unstable income for the farmers. The timely knowledge of the occurrence and severity of upcoming weather events and the current phenological stage of crops is significant information for the development of risk management tools, but also the optimization of farm management and the control of inputs. One example is the early picking of cotton bolls during the boll opening phase, in the case of an approaching extreme weather event. In this context, farmers, agricultural consultants, and agricultural insurance companies could benefit greatly. Big Earth observation data, like the Sentinel data, that cover large areas with high frequency and at high spatial resolution, have introduced new opportunities for the large-scale monitoring of phenology. In order to predict the occurrence of an imminent extreme weather event, atmospheric parameters from numerical weather prediction models are exploited. The phenology stage prediction methodology consists of two steps. Initially, a time series comparison algorithm is used to generate predictions based on a limited number of labeled parcels. The second step involves utilizing the predictions from the first step as pseudo-labels to then train random forest regression models. The time series comparison methodology is based on the one versus all comparisons of the Sentinel-2 time series of a parcel with the ones from the labeled dataset. Since phenology is dependent on the relative temporal progression of features and not their absolute values, the final parameter space consists of the slopes of the time series with a step of 5 days, as shown in the algorithm here. The labeled parcels are few and the extracted knowledge from those can only be fully representative for parcels of the same region and of similar agroclimatic conditions. Therefore, the time series comparison prediction was applied to 1,000 cotton parcels in close proximity to the labeled parcels. Due to the lack of available ground truth information and the need to generalize the phenology estimation methodology to be applicable in other areas, we examined the pseudo-labeling approach using those first predictions as training data for a random forest regression model. Since the phenology prediction methodology needs to be dynamic and capable to execute at any time instance, multiple random forest models are trained for every 5 days throughout the growing cycle of cotton. The mean absolute error of the two methods has been averaged over all predictions for the 97 field visits we performed for validation. The pseudo-labeling method resulted in a mean absolute error of 6.88 days, while the random forest regression model in 5.82 days. The results are satisfactory, particularly given that the different plants in a parcel do not all grow exactly at the same pace. Therefore, both the labeled and validation data are subject to observation errors. The results are within the limits of this aggregation error. This work has recently culminated into an operational web platform. Here we see the optimal sowing day maps using the numerical weather predictions of this study. 3 farmers' cooperatives in Greece have used this service operationally during the start of cotton's cultivation season. The user is provided with a suggestion if seeding is recommended for their parcel or not. Here we see the growth platform that includes the phenology prediction service that was described earlier. The user is provided with a major and minor phenological stage for the parcel along with a percentage of completion for the major phenological stage that describes that parcel. This web application was developed in the context of the Horizon 2020 project eShape. Thank you.